Hello, good evening. I welcome you all for this session on analysis of GATE Electronics and Communication Engineering paper. You have written the exam in today's GATE examination. I hope and pray that all of you have fared well and you are going to get very good rank in the GATE exam. I would like to analyze what exactly the type of questions that have appeared in this GATE exam. And before going to that, we have collected the questions appeared in today's GATE exam from various sources. And most of the inputs in this regard, they have come from the students. So we have taken the inputs from the students and we have compiled it, and in today's class we are going to give the solutions to those problems. So the data what we are giving may not be 100% accurate. There might be little deviations here and there. So once the complete information about the questions come, then we are going to provide the proper solution to that. Today, all the experts in different subjects are with me in order to discuss the solutions for the given questions in today's exam. So I will call them later on one by one. After going through the questions given in today's GATE exam, we found that the paper is not easy, at the same time not difficult, it is little moderate. So the students were having good fundamentals, good understanding of the fundamentals, they would have definitely fared well in this exam. Some of the subjects, the questions were easy, I will show you that later on, and some of the subjects, the questions were little bit difficult. So if you fared fairly well, then you can definitely get into the rank below 300 easily. If you look at the distribution of the marks and how the marks have come, let me show this table. Subject-wise distribution, if you see here, so first one, let's start with the control systems. 3 2-mark questions have come from this and 1 1-mark question have come from here. So totally it is going to be 7 marks. And if you come to digital circuits, fairly good number of marks have come, that too they are very easy. I say digital is a very big boon for all the students because it's easy to answer to them. So 11 marks are in your basket if you answer it properly. So you can see that 4 2-mark questions and 3 1-mark questions have come. This time also there is no question from computer organization, unfortunately. And from electronic devices, which is one of the very important subject, all through the years we have seen in the GATE exam, 3 questions have come for 2 marks and 2 questions have come from 1 mark. Some of them are easy, but some of them are very difficult as well as moderate. We will discuss it, the concerned faculty will discuss about it. Signals and systems. Here totally, actually this figure is not properly right. So totally 4 2-mark questions have come and 1 1-mark question has come. That is 8 plus 1, 9 marks have come in signals and systems. And coming to the communication system, it is 5 2-mark questions and 3 1-mark questions. Totally 13 marks have come in this. I think it's going to play a very, very important role in getting a good rank. If you have failed 50% well in this subject, I'm sure you will get into IITs. Okay? Other subjects, another important subject, analog circuits. If you see, 2 marks questions are 3 and 1-mark questions are 4, so the total marks are 10 for this. And engineering mathematics, of course, this is also one of the important subject along with the technical subjects, as we know. Always we emphasize this at the beginning of our coaching. 5 2-mark questions are there and 6 1-mark questions are there. So that is also going to be a crucial point in getting a very good score. Network theory, this time I can say the importance has come down little bit for network theory compared to yesteryears, and also questions are easy, okay, it doesn't require much practice. 3 2-mark questions and 2 1-mark questions are given. And coming to the electromagnetics, 2 2-mark questions and 2 1-mark questions are given. Luckily, the questions on EMT are easy and little bit moderate, so with clear fundamentals, we can answer them successfully. In general aptitude, of course, this is also going to play a very important role in order to get a good rank in the GATE exam. 5 2-mark questions and 5 1-mark questions, totally 15 marks have been given here. So overall, if you see, there are 30 1-mark questions and 35 2-mark questions are there. As I told you, this may not be so accurate because we have collected the information from students. There may be little deviation here and there. Okay, we will correct it once we get the clear information. But as of now, we wanted to give what exactly the type of questions we have got it. But one thing is sure, after going through the questions, we found that all this format of the questions have been discussed in the coaching across the platforms. Take deep learn, take online or take offline. In all these coaching classes, these type of questions have been discussed. So if you have followed them thoroughly, answering to these questions is not a big thing. I think you would have totally fared well in the exam. Okay, so with this introduction, I would like to tell what are the fine points in this one. The overall paper standard is moderate to difficult. As I told you, it's not too easy, but it's moderate to difficult. And first time, the main difficulty students have faced is more number of MSQ questions have come, unlike yesteryear. 14 MSQ questions. You know pretty well, the problem with MSQ question is, even though question standard is simple, in order to select multiple answers, you need to have the clarity of the fundamentals. That comes by practice, okay? Otherwise, your chance for fumbling. And then, general aptitude questions are also easy this time, not a very big thing. As I told you earlier, the digital electronics network theory questions are easy and they are going to be very positive for the students. But mathematics, electronic device and circuits, and the communication, these questions are a little bit tough. Especially the questions in digital communication, they are little tough. So overall, if you see here, 33 MCQ multiple choice questions have come in the exam, and then 18 numerical type questions have come in this. So this is the outline of the paper, what you have got today in the GATE exam. Right. So along with me, all the subject experts are here. I will invite them one by one once I cover my discussion here. So digital circuits, as I told, there are 4 2-mark questions and around 2 1-mark questions have come. I will cover 2 questions first and then I hand it over to my colleague. Yes. As I told already, there may be little deviation. Don't think that this problem is final, whatever I given here. Okay? But according to my understanding and information got it from the students, I have written it in this form. It's telling that y is equal to a plus b bar. Then which of the following is/or is true? Okay. Whenever you have is or, you know that it is a multiple select question. That is the hint. Then what is the meaning of this? He told which option is correct one, which options are correct one. That's it. One thing is sure, if you look at the expression here, if you are clear, all gates can be obtained by using such type of expression. Because when you make a is equal to 0, y will become equal to b complement. That means it is acting as inverter. So once the inverter comes, I am very sure that AND gate, OR gate, NAND gate and NOR gate outputs can be obtained. Let me show that. So how to obtain the NOT gate is nothing but make a is equal to 0. That's it. So now this is going to act as an inverter, right? So with the help of this inverter, okay, from now onwards, I'm going to call this as NOT with a black symbol. So how to get OR gate? So try to understand here. I am going to keep one NOT gate which is obtained from this top discussion, that I am going to use it here. So keep one inverter extra which is shown with yellow line. If I show that it is going to become an OR gate, that means I will show that implementation of this one here. A plus B bar is the original one, so what I do is I will keep a NOT gate. That means the OR gate is obtainable using this given logic gate. Okay, like this we have to see about AND gate. So you try to convert this expression in such a fashion that it is going to resemble the given expression A plus B bar. Once I can do that, then it's easy to do. For this what I do is take its double complement. So I'm going to take it as AB so this is going to become, as you know, A bar plus B bar plus bar. But with the given gate, what is the actual expression it can implement? It is nothing but A plus B bar only. But apart from that, we require some extra NOT gates. Whatever NOT gates we have obtained here, that I can use it. How many of them I have to use? Look at the expression. 2 more I have to use. So let me give them. First one is this, and second one is this. That's it. So to the original expression of A plus B bar, if I can use 2 NOT gates, I can obtain AND gate. Are you going to use a NOT gate means original inverter? No, don't do that. This is also NOT gate obtained from the given gate, this one only. So this is the NOT gate I am going to use. So if I use 2 of them, one at the input, one at the output, this is going to become your AND gate. Well, let me show the quick implementation of this. That's it. So in this fashion, I can obtain OR gate. And similarly, what about NAND gate? I think just before this NOT gate, if you look at the expression, A bar plus B bar is nothing but AB whole bar. That means it is nothing but a NAND gate. So meaning we can implement a NAND gate as well as we can implement a NOR gate. So now look at what are the options he has given. So he told that AND gate cannot be constructed. This is wrong. Because using this gate, AND gate can be constructed. OR gate cannot be constructed. This is wrong. Because OR gate can be constructed using this. NAND gate can be constructed. This is true. And NOR gate can be constructed. This is true. So the final answer, if you analyze it in this fashion, is C is the correct answer and D is the correct answer. So that is what the first question here. Coming to the second one. A 2-bit counter is connected to a JK flip-flop in this fashion. Then he is asking if the clock frequency is equal to F0, 25% duty cycle, then what is the frequency at this output Q and what is its duty cycle? Actually speaking, if you think carefully, the input clock duty cycle is immaterial. 25%, it's not going to help you in getting the solution. That you can simply discard it. Okay, right. So always remember, if counter is given, if it is not mentioned what type of counter it is, we have to take it as up counter. Okay, just to get the clarity, I am going to use it as Q1 and Q0. This is most significant bit Q1 and this is Q0. So just as a note, for every clock pulse, how this Q1, Q0 values are going to change. Initially it is equal to 0, 0. For the first clock pulse it becomes 0, 1. Second clock pulse 1, 0. Third clock pulse 1, 1. Again it comes back to 0, 0. Like this it will continue. As you can see here, this is your least significant bit. This is your least significant bit. and that is connected to JK inputs. What's the meaning of this? When Q0 is 0, that means JK inputs will be 0, 0. At that time, output will not change. When LSB is 1, at that time, JK is going to be 1, 1. Once it is 1, 1, for the next clock pulse, it is going to toggle. You can observe the same clock is connected here and here. Okay, then what is the output I am going to get? Two methods we can do it. One method is by sketching the waveforms at Q0 followed by at Q, we can obtain the output. Okay, or else I will prepare a table which looks like little lengthy, but you will understand the concept with that. So let's go to the method 1. Let me take some clock pulses here. He told that it is having 25% duty cycle, but for this solution, it's not so important. Yes, and now you see the previous column here. For every clock pulse, it starts with 0 and it is going to toggle. It is going to toggle. I'm going to focus on Q0 value. So the Q0 waveform looks like this. So it is a positive edge triggered one. So at every positive edge, Q0 is going to change. This process will continue. Okay, fine. So these are the positive edges. Isn't it? Okay, so I have drawn what is the Q0 output here. Now the next thing is this Q0 is going to decide the value of JK flip-flop such that what happens to the Q output, we can see it here. Look, at this positive edge, you have to take just the previous value of this. Q0 input is equal to J is equal to K. This is equal to Q0. So at this point, you should understand this is 0. Okay, for this positive edge, this is going to be 0. For this positive edge, it is going to be 1. Input is 1. For this positive edge, it is 0. Just before this. For this positive edge, it is 1. For this positive edge, it is 0. What is the meaning of this is 0? J is 0, K is 0, output remains same. What's the meaning of Q0 is equal to 1? Look at the previous circuit. When Q0 is 1, JK inputs will become 1, 1. Once it is 1, 1, it goes into toggle mode. So that's what we need to understand. So according to that, I will draw the output waveform. So initially it's equal to 0. So I'll just highlight these positive edges so that you can understand here the transition takes place. This positive clock is common even for last flip-flop, right? As it is 0, it is JK is 0, 0, that means output remains same. Here, for this positive edge, Q0 is 1, that means JK is 1, 1, because of that it toggles. This positive edge, input is 0, that means JK is 0, 0, means output is going to remain same. At this positive edge, Q0 is 1, means JK is 1, 1, output toggles. So this process will continue. Again 0, it is going to continue, that's it. So he is asking the question, again here, somewhere here, it's going to change its output, right? So what is the time period of this? What is the frequency of this output? What is the duty cycle? That's what you need to find, okay? So finally, you can see that this is its time period. So this is going to be equal to, starting from here, 1, 2, 3, 4. So T naught is equal to 4 times T. So that means output frequency F naught is equal to F by 4. By the way, what is the duty cycle of the output? You can see here the on time is equal to off time. It is a perfect square wave, means it is having 50% duty cycle. T naught on will be T naught divided by 2. So the final answer is output frequency will be equal to F divided by 4, where F is the clock frequency and the duty cycle is 50%. As you can see, whatever duty cycle he has given for the clock input, that is immaterial in this problem. Okay, that's what you need to realize it as soon as you read the paper. Okay, I will cover remaining questions on digital after some time. Now I request my colleague Trinath to come over and solve questions on unlock circuits and EDC, one question each.
Hello? Yeah, hi dear students, a very good evening to everyone. So electronics and communication, I think like you have rocked this exam, GATE exam 2022. So wish you a very all the best for a great success in this exam, dear students. My name is Trinath. I'm the faculty of ACE Academy, one of the faculties who teach two subjects, electronic devices and analog circuits. Students, here let me discuss about the metal oxide semiconductor field effect amplifier circuit given in analog circuits, okay? This is given for numerical answer type questions, 2 marks. This is the data what we got exactly from the students who gave up this exam through ACE Academy. Students, check it out the question. Consider the circuit shown with an ideal long like channel, N-channel MOSFET, which is working under exactly enhancement mode. Whenever you're considering about the circuits, I discussed in the class number of times, default MOS circuit, we are supposed to take it as enhancement. We never go with a depletion. At default, either you're going for a CMOS technology or amplifiers, we always consider enhancement. That means a minimum channel we are supposed to provide to produce currents. The gate to source voltage at least must be greater than or equals to the threshold voltage to produce the channel, then only we would be getting the currents. Correct or not, dear students, right? So the substrate, of course, they have given. The transistor is approximately biased in the saturation region. We are so lucky. The transistor is, that means the quiescent point. The quiescent point is biased in the saturation region, fine. So like it is acting like an amplifier, linear amplifier, very fine guys. So the input voltage, what they have given as a small signal, AC input. Now we are supposed to find the ratio, that is VA by VB. Very interesting. So this is the circuit what they have given. Yes, it is. This is very simple circuit, I understand. Having gone through this circuit once carefully, dear students, if I give input to the gate and if I take output at the collector, it is simply behaving like a common source amplifier. Whereas the same input if I give into the gate and if I take output across the emitter, it will act as a source follower. Correct or not? Input is gate, output is a source. We say source follower or we say a common drain. Input is given to the gate, output is taken across the drain. It acts as a common source amplifier. That means the same transistor for multitasking we can use. Anyways, our task is what, dear students? We are supposed to find the ratio between voltage VA with reference to VB. Fine. So they have clearly specified the small signal gain. Let me move into a small signal model, a simple RE model or 1 by GM model. By that, I believe we could save a lot of time. And one more interesting fact, in this given question, early voltage, they have not specified. That is output resistance R naught, they have not specified. So if no condition is given, we consider every amplifier without any loading effect, correct or not? Indicates early voltage, we could take it as infinite or R naught could be taken as infinite. So in that case, if I draw the AC equivalent diagram over here, students, like this is 1 by GM, correct dear students? It's like 1 by GM and here the source we have, here like the drain current I say simply I, correct or not dear students, right? And this is the drain and this is the gate. Correct guys? Now, so externally what components we are supposed to connect over here? AC circuit, AC equivalent, indicates all the DC parameters must be taken as grounded. DC voltage should be shorted, DC current source must be taken as open. Now dear students, I understand here we could provide the 4 volt like which is 4K. So here it is nothing but what, dear students, which is 4K, and here this is the voltage VB. I'm sorry, it is VA, I think, correct. This is VA, correct or not, dear students? This is VA connected to the drain part. In the similar way, the source, at the source we have connected the resistor, which is nothing but 2 kilo ohm resistor, and here this is the voltage at the B. Output is taken across source. If you take that is a load, and no doubt this is your NMOS, and at the gate, yes, simply we are providing the input voltage. That's it. And here we could take it as simple as 0 volt. And drain current is always equals to the source current. In case of your field affected transistor, the same current could be considered over here. Here I need not to find any gain, okay? I need to find the relation between VA and VB. That's it, as simple as like that. Now students, now could you please suggest me how can I do this? That VA, the voltage at the terminal drain, I think that is minus I into 4K. Correct, dear students? In the similar way, what is VB? The same current is propagating the source voltage with reference to the ground. Therefore, plus I into 2K. That's it. Oh my God. I think within 2 steps, I believe we could get the answer here. So what could be the relation between VA by VB? I think that is what exactly they're asking. Check it out, dear students. VA by VB. Fine. So VA by VB, if I take like minus I into 4K by 2K. So the answer for the question VA by VB is like minus 2. That's it. Minus 2 is the answer. Check it out once. You get the correct answer or not, dear students. That means if the data provided by our students, if this data is correct, then this answer must to be correct, minus 2. Right, dear student, this is one of the very interesting questions in analog circuits. Yes, numerical answer type questions. We came to know that, asked for 2 marks. Fine. Now let me do one question in electronic devices, okay? I'll go with this question. Yes, I'll do this question, okay? Right now, I'll do this question. In a non-degenerated semiconductor, if electron density has given, now the value of EC minus EF, that is Fermi energy level, they have provided the Fermi energy, the difference between EC versus Fermi energy have given with respect to the conduction band. Then for, I understand he changed the concentration of electrons. I think it is N-type semiconductor, the concentration of electrons got modified, okay, fine. Then find the approximate value for EC minus EF. Very simple question. But try to understand a point. They have clearly specified it is non-degenerated semiconductor. When you hear the word non-degenerated, understand in case of N-type semiconductor, Fermi level must be below conduction band. In case of P-type semiconductor, Fermi level must be above valence band. If it is a degenerated semiconductor, Fermi level must be inside the conduction band. And if it is N-type, whereas Fermi level must be inside the valence band if it is P-type, if it is degenerated. Second important thing, as they have clearly specified it is a non-degenerated, a Boltzmann approximation is successful. That is, I believe you know that, the Boltzmann approximation EC minus EF greater than or equals to 3 times KT, the Boltzmann approximation. It need to be satisfied. If it is satisfied, then only we can enter into the formulas what we have studied regarding this type of Fermi energy analysis. If this Boltzmann approximation is not satisfied, you can't use the formulas like what we studied like concentration of electrons. One more important thing here, for non-degenerated, because of the Boltzmann approximation valid, directly we can use the formulae, the concentration of electrons with reference to the conduction band, N is equals to NC into exponential EF minus EC by KT. I believe you remember this number of times. We have discussed this in the class. But this is valid only when Boltzmann approximation is valid. Correct or not, dear students? Only when Boltzmann approximation is successful. Sorry, I think. Yes, do one thing. Let me read out that expression again. Yes, fine. Technical glitch. Right, guys, anyways, concentration of electrons over here, N is equals to NC exponential EF minus EC by KT. This is valid only when Boltzmann approximation is successful. Yes, non-degenerated semiconductor, it is valid. Now, dear students, now he has clearly mentioned EC minus EF. So you can understand, like if I say this is EC, the Fermi energy level is very near to the conduction band, EF. And this difference they have clearly specified. That difference is 200 milli electron volt. That difference they have specified, 200 milli electron volt, when the concentration of electrons N is equals to provided as 10 power 16. That means what? For N is equals to 10 power 16 per centimeter cube concentration of electrons. Correct, dear students? So what data he has given? EC minus EFN is equals to how much, guys? 200 milli electron volt. Fine. Now the doping concentration is modified, or we say the concentration of electrons getting modified. Let me say for N is equals to, how much they have given? 0.5 into 10 power 16 per centimeter cube. So we are supposed to find EC minus EFN is how much? This is the question they have clearly asked. And as they have not specified anything regarding the temperature, we can take the temperature could be maintained constant. Have you remembered the concept in the class, dear students? If temperature is maintained constant and if the doping concentration is increasing, the Fermi level move towards the conduction band. Whenever doping concentration increases, Fermi level move towards the conduction band. Students, the previous doping concentration, it is 10 power 16. Now the modified doping concentration, I could say it is like 0.5 into 10 power 16. What it represents? The doping concentration is getting decreased. Whenever doping concentration is getting decreased because of the temperature constant, I could say the Fermi energy level could be moved away, slightly away from conduction band compared to the previous case. Indicates I need to get the answer greater than 200 milli electron volt. Very straightforward. I should get the answer greater than 200 milli electron volt. Let me check it out. 174 milli electron volt, absolutely wrong. Here we have 182, absolutely wrong. So we have 218, we have 228. So in both, any one answer, you could get the correct option. Okay, let me check it out that. Now, dear students, could I consider this as like, students, like can I say this is N1 and say this is N2? By that I could say EC minus EF of the first one, EC minus EF of the second. Can I say in that way? Then, dears, can I go with the subtraction like that? What? Yes. I'm sorry. Students, like, see, this is the formula, right? N is equals to NC exponential EF minus EC by KT. Therefore, students, please let me know here. Please let me know here. What about EF minus EC? EF minus EC is equals to KT log mod, speak out, dear students, N by NC. Of course, it is natural logarithm. Correct or not, dear students? N by NC. Therefore, what could be EC minus EF? EC minus EF is equals to KT natural logarithm NC by N. Now, if I say this is for first doping concentration and the same for second doping concentration, then can I do in this way, dear students? Directly can I move in this way, dear students? So, EC minus EF2, that is meant to say second doping concentration, minus, can I say in this way? EC minus EF1. Directly, I think I can use this. So, EC minus EF2 minus EC minus EF1. Then what I'm going to get here, dear students, that is KT log mod ND2 by ND1. Of course, basic, natural logarithm. Or I mean to say it is denominator, not, dear students? Yes, it must be like N1 by N2, I think, correct? N1 by N2. So what is the doping concentration of N1 they have provided here, dear students? N1, yes, 10 power 16, and it is 0.5 into 10 power 16, yes. Therefore, EC minus EF2, which equals to, what is EC minus EF1? That is, with respect to the initial doping, what could be the difference energy? So 200 milli electron volt. So 200 milli electron volt, yes, plus, right, KT, that is K into T at 300 degree Kelvin. What could be the value, dear students? Like 0.026 electron volt, because that is energy. KT by Q will be the voltage, thermal voltage, into log, okay, natural logarithm I say. What is N1? 10 power 16, and what is N2, dear students? 0.5 into 10 power 16, that's it. If you could solve this, you will be getting this answer, dear students. So I understand the answer for the given question. So I believe you could solve this, okay? I understand this could be the answer. 218 milli electron volt for this numerical. This is one of the questions asked in electronic devices in GATE 2022. Of course, we have many more questions in analog and electronic devices. So some more questions I'll be solving soon, dear students. So let's welcome to our professor who teach electromagnetic transmission lines in ACE Academy.
Okay friends, welcome back. Good day. Hope you had a wonderful day. Now let us deal with the questions which are related to the electromagnetic theory. See, these questions are collected from the student community through the various channels. Fine, okay. So there may be some deviation with the actual questions, but let us try to give, I'll try to give the most possible answer to the questions what we have seen in the today's session. Fine, so these are the questions here. Directly we'll jump into the question. It is related to the wave equation. Fine. Consider the following wave equation. This is a wave equation. Dou square by dou t square f of x comma t is equal to, here it is actually square here f of yes x comma t. This is a wave equation. Second order variation in the space and second order variation in the time. Here it is 10,000. Which it's the following option A solution to the given equation. So this is a wave equation, right? Second order wave equation, second order variation in the space and second order variation in the time is a wave equation, right? So you can compare this one with the standard form. It was given for 1 mark. What is the standard form in general you have for the wave equation? The standard form, if we consider x directed wave, it would be something like this. Dou square by dou x square of f is equal to 1 by c square into dou square f by dou t square. So here dou square by dou t square is given, you can bring that c square other side. So this will become dou square f by dou t square is equal to c square into dou square f by dou x square. Fine. So it is something similar here, you can notice. So in the place of c you are having 10,000. Done. So what would be the c value here? The c value is c square is equal to 10,000. C square or v square we'll call, v square actually instead of c square. Why? Because the c symbol is used for the velocity of the light. You can use what is called a v symbol here to be more correct. Here it is v you can use. Fine. So the v is equal to 100. Fine. So what is the general solution for this equation actually? You can just recall your concepts. The general solution for this equation will be something like this. So the general solution for this one, which is a function of x comma t, will be some function of, this function can be anything. It can be a sinusoidal or cosinusoidal, rectangle, triangle, whatever it may be. So which is equal to x minus or plus vt. There is a linear shift, isn't it? It is a wave equation. It is a general solution. So the solution must be in this form, x minus vt form. Fine. So whichever the solution is having this form, this generally this is called wave variable x minus vt. It is a right shifted wave. X plus vt will be a left shifted one. You would have learnt in your signals and systems, isn't it? The same story here. So the solution should contain the variable x minus vt as well as x plus vt. Fine. So check out the options here. X minus vt, in the place of v you are having the 100. X minus vt and x plus vt. See here, here the function is exponential, e to the power of minus, x minus vt. Here x minus vt. So here there is a x minus vt. Yes, here it is x minus vt. Here there is a sign of function, it is a sine function. Okay, so here it is x minus 100t, it is x plus 100t. Let me check out the options here. So there is some printing mistake. Let me check out the options. Some other options are there. There may be some 1000 here. Fine. So here x minus vt, x plus vt, here it is plus. Okay. So this is correct. This is also correct. This is wrong. Here there is a 1000 is there. So it is not the answer. Here it is the 400 minus t. It is 1000 plus t. It is also wrong. So something this question related to the wave equation, isn't it? The solution ultimately options may be anything, isn't it? As I said earlier, there may be some deviation with the actual question, but ultimately the concept here is you should have to check the solution. The option should have the variable something like a x minus, right shifted wave as well as a left shifted wave. So whichever is options having, it is a multiple select question. Fine. So option A and option B are the answers for this one. Fine. Let us take one more question. It was very simple question. Yes, here is a question. You can take this question as a vector calculus question from your mathematics. I'll take this as an electromagnetic theory question. This question is something related to the Stokes theorem. Why? Because here is a vector field given. You can just read out this one. X into I cap plus y into j cap. And I and j, everything, rest of the things are very common. Is asking us to find out what is called a closed line integral here. Closed line integral of f of x comma t, a dot product with dx x cap plus dy y cap. Options are provided. Yes. So actually speaking, you need to integrate over this section, this section, this section, this section. It would be a trivial thing. It would be a lengthy one, isn't it? Of course, this was asked only for 1 mark. So something is there here, isn't it? So you need to use what is called a Stokes theorem. Let us use the Stokes theorem here, so you will get some clarity. So what is the Stokes theorem? Integral here is a closed line integral of f dot dl. It is what is asking. So if you go by this one, you need to integrate over the 4 sections, isn't it? Over this section, this section, this section, this section. And it is not a straight one, it is a curved one. Then the coordinate system would be very difficult. Deciding the limits is a very big task. Yes. So there must be something, as it is asked only for the 1 mark. Let us go by the Stokes theorem here. Fine. So what is the Stokes theorem? It is surface integral of del cross f dot dA. Fine. Yes. So find out the del cross f, cross product of this one. So del cross f is equal to, you have to write the unit vectors x cap, y cap, z cap. Dou by dou x, dou by dou y, dou by dou z. And what are the x, y and z components here? X component is x and y component is y, z component is 0. Interesting. You will get interesting result here. So the x cap into, you can perform the determinant here, this into this minus this into this, 0 minus 0, minus y cap into this into this minus this into this, 0 minus 0, plus z cap into this into this minus this into this, 0 minus 0, partial differentiation, which is equal to 0. Arre? Isn't it? It was asked for 1 mark. Fine. So here the curl is equal to 0. You can get the answer from here itself. So this part is equal to 0. Obviously, the closed line integral will going to become 0. It is a conservative field. Yes, integration is only dependent on the location of initial and location of final point, but not on the shape of the contour chosen, isn't it? It may be something like this or like this, doesn't matter, because the curl is 0. So this closed line integral will go 0. Fine. So option A is the answer. Clear? Fine. Let us proceed further. Here is a question. Yes, this is something related to the parallel plate waveguide. Very direct and straightforward here. Let me check out. Yes, it is a parallel plate waveguide. Let me check out the data here. Yes. Yes. Here it is, there is a spacing is provided. A waveguide consists of the two parallel plates. Perfect conductor at a separation of 10 to the power of minus 4 centimeters. With an air as an electric medium. The speed of the light in the air is 3 into 10 to the power of 8 meters per second. The frequency of the TM waves which can propagate in this waveguide is R. Fine? Yes? See here, what is the cutoff frequency for the parallel plate waveguide? It is not mentioned, parallel plate waveguide is not mentioned in our syllabus, but the parallel plate waveguide is a special case of the rectangular waveguide, isn't it? You can suppose if you are dealing with a TE wave or a TM wave, you can make one of the integer 0. That leads to what is called a parallel plate waveguide. Here also story remains the same. So what is the cutoff frequency? The FC is equal to, generally we used to have for the parallel plate waveguide 1 by 2 square root of mu epsilon square root of m by a whole square plus n by b whole square. This is for the parallel rectangular waveguide. You can make one of the integer 0. You will going to get it for this one. So here it is 1 by 2 square root of mu epsilon into m by a. Yes, this is true for the TE wave as well as for the TM wave. What is the lowest possible for the parallel plate waveguide? TE11. Sorry, TE1 is the lowest. For the TM wave in the parallel plate waveguide is the TM0. Fine. So, but here is given the finite values. Fine. So now let us check the different values here. You can check out this one. This part can be written as a velocity of the light because the region between the two parallel plates is the air. Fine. So this will become Fc is equal to 3 into 10 to the power of 8 divided by 2 into A into M. Fine. So let us try to find out. You can substitute M is equal to 0 also. Fine. But we are dealing with a finite value here. Let me turn the page here. So let us consider M is equal to 1 here. Fc is equal to, how much is that? 3 into 10 to the power of 8. 3 into 10 to the power of 8 divided by 2 into 10 to the power of minus 4 into centimeter, right? 10 to the power of minus 2. 10 to the power of minus 2. So check out this value. How much is this? Come on. It is 1.5 into 10 to the power of, you can take this one, 10, 14. So it is the waveguide is a high pass filter, right? Whatever the frequency is greater than that cutoff frequency, the waveguide will going to support. Yes, please check out what are the frequencies which are greater than that 1.5 into 10 to the power of 1.5 into 10 to the power of 14. So 1.5 into 10 to the power of 14, this is greater than that, so this will be supported. This is less than that, it will not be supported. This is greater than that, this will not be supported. This is, these are supported. This is less than that, it will not be supported. This is greater than that, this will be supported. It is less than, it will not be supported. Clear? Done? Fine? Okay. So very simple. Fine. So you need to find out the cutoff frequency, then whatever the frequency is given which are greater than that cutoff frequency, waveguide will going to support that because waveguide is basically high pass filter. Fine? Fine. Let us deal with the one more question here. Here is a question. It is a very simple, straightforward question. You can take this as a RC circuit question, but some basics are required here. He is talking about the RC circuit, but the concept of the displacement current is included into this question. Yes, the same things was noticed in the communication also. He has clubbed the two concepts. One is the transfer function concept and the pre-emphasis and de-emphasis concept. He has done those experiments in the questions. Generally, that is what happens in the GATE exam, isn't it? You cannot treat one subject isolatedly. You will club 2 or 3 concepts so that how well you can deal with those concepts. You can combine those concepts and you can deal with the questions, isn't it? That will what will going to be tested in this exam. Fine. Please read out this question here. In the circuit, there is a series connection of the ideal resistor and ideal capacitor. The connection, the conduction current, it is actually conduction current through the resistor is this one. Okay, 2 into how much is that conduction current? Conduction current I of t is equal to, you can just write down like a conduction current IC. IC is equal to how much is that? 2 into sine t plus pi by 2. I didn't get any information regarding the option D, isn't it? That's the reason why I left blank. Fine. So what is asking the displacement current through the capacitor. So from your concepts of electromagnetic theory, especially from the Maxwell's equations, we know that especially for the parallel plate capacitor, conduction current is equal to displacement current, isn't it? It is only true for the parallel plate capacitor. Fine. So it's asking for the displacement current here. But there is a magnitude wise they are same. But there is a difference in the phase, isn't it? So what is the conduction current? If you just recall, conduction current is equal to sigma into E. And what is the displacement current? JD. JD is equal to dou D by dou T. Better I'll write this one in the phasor form. Fine. So this dou by dou T can be replaced with the j omega and D can be replaced with the epsilon into G. So you can easily check out from here, there is a phase difference of 90 degrees. Fine. So magnitude wise they are same. Conduction current and displacement current, magnitude wise they are same, especially only for the parallel plate capacitor, but they'll differ with the phase of 90 degrees. Clear? Fine. So obviously, so here it is 2 sine t plus pi by 2. Obviously here also you're going to get 2 sine t, but there is a change, there is a difference of 90 degrees, isn't it? Option B is answer. Clear? Done. So let us take one more question here. Yes, here is a question. This is something related to the Gauss law. Very simple question. Fine. So how many questions we have discussed so far? 1, 2, 3, 4, 5. Yes, this is the last question. Fine. It is a very simple and straightforward question. In an electrostatic field, the electric displacement density vector D is equal to x cube x cap plus y cube y cap plus x y square z coulomb per meter square is given. So he is asking us to find out what is called lot of. Just a minute. There are some printing mistakes. Fine. Okay. So here consider the critical region R at an origin with each side of length how much? 1 meter vertices at x comma y comma range x comma y comma limits are ranging from -5 to -0.5 to plus 0.5. There are some small mistakes here. This is the limits. Sorry. Okay, ultimately we are interested in the concept. As I said earlier, there is some, yes. So he's asking us to find out charge enclosed within that region R. Fine. So from the Gauss law, what we know? It's very simple and straightforward, this one. From the Gauss law, we know that charge enclosed ENC is equal to net electric flux. That can be written in the vector form as a closed surface integral of D dot dA. But if you consider this one, this is a box of whose side is ranging from -0.5 to +1, it will going to have total 6 faces. That side, this side, upward, downward, that side, this side, left side, right side, isn't it? Total 6 faces. You need to integrate over total 6 faces. It is a waste of time. Directly use divergence theorem, isn't it? So what is the divergence theorem? A volume integral of divergence of D into dV. That's all it is, isn't it? Fine. So perform the divergence. What is the divergence of this one? 3x square plus 3y square. Yes, I'm going to turn the page here. So the divergence of D, I'll directly write down this one. Divergence of D is equal to 3x square plus 3y square. Now, total charge enclosed is equal to volume integral of divergence of d 3x square plus 3y square into differential volume is dx, dy, dz. Fine. So you can take that differential volume inside and you can separate out the variables here, 3x square into dx. I am writing, you can, if you want, you can write in the 2 steps. Here, so here it is symmetrical. Yes, whatever the answer you are going to get with this one, the same answer you are going to get with this one because the limits are same, x, y, z limits are same, isn't it? Fine. So you can just take it as a 2 into this one, okay. So here it is 3 into x cube by 3. The limits are from minus 0.5 to plus 0.5 into y, limits are from minus 0.5 to plus 0.5. So minus 0.5 to plus 0.5. So whatever the answer you are going to get for this term, same value will be repeated for this one. I'll multiply with the number 2 just to save the time. Fine, 3 will cancel out. Here you can check out this one. You can find out its value. Yes, how much is that? So here it is 2 into 0.5 cube minus of minus 0.5 cube. So here it is 2 into 0.5 cube into this one is 0.5 minus of minus 0.5. It is 1 into 1. So you can check out this value 4 into 0.5 cube. It is 0.125 something like that, isn't it? So we are going to get the charge, total charge enclosed is equal to 0.5 coulombs is the answer. It is a numerical answer type question. Fine. So just I want to reiterate the same thing. There may be some minor or major deviations from these questions, isn't it? Fine. So, but ultimately these are the concepts and this is the approach you need to follow for the questions which was asked in the today's session. Fine. So, if at all, if there are any alterations is required for these questions, always welcome. Fine. But these are the 5 questions which were noticed in the today's session. But let me be extremely honest, frank and bold. Unfortunately, there is no question from the uniform plane waves and the transmission lines and antennas. It's a very unfortunate thing as a electromagnetic theory point of view, isn't it? That's what I can say. Fine, whatever it may be, students' point of view, these questions are very simple, very moderate. Fine. So this is all about the questions, very simple. One is a wave format, other one is you can take this as a vector calculus question. Fine. So I'll hand over the session to the other faculty. Fine. Good luck.
Hello students, I am Kiran Kumar, faculty of ACE Engineering Academy. Let's look at analog circuits. So find the maximum and minimum values of capacitor voltage. So this is a standard relaxation oscillator. So you all know that the output of a relaxation oscillator is a square wave generator. And this capacitor maximum minimum voltage is going to be the difference between the UTP and LTP. So let's try to solve this. Let V0 is at 15 volts. If this is 15, we all know that D1 is forward. So this resistor becomes dummy. This is a simple voltage divider. So you have R and R, which is 2R, 15 volt, and here you have R. So the upper threshold point is going to be 15 into R by R plus 2R. So this is going to be 15 by 2 plus 1 is 3, so 15 by 3, so which is 5 volt. Now what happens when the output flips from plus 15 to minus 15? If it flips from minus 15, D2 is going to get on. This R is dummy now, and this is a simple voltage divider. Let V0 is at minus 12 volts. So this is R, and you have 2R here. So this is R and 2R. So now with minus 12, so you can tell me that this output is going to be minus 12 into 2R by R plus 2R. So this is minus 12 into 2 by 3. So this is minus 8. So if the UTP is 5 and LTP is minus 8, the difference is going to be 13 volt. So if you want to know, we can draw the waveform, if at all, if maybe you'll be interested in this. This V0 output is this waveform. It's a square wave, and it is going to flip between plus 15 and minus 12. Minus 12. So let's assume if the output is at plus 15, then this capacitor is charging towards 15, but once it crosses 5 volt, it's going to flip. So this is going to be the waveform. And once it is minus 12, he's going to reach here to minus 8. So the examiner, he's asking you the difference, which is 13 volt. So this is a simple question. I mean, we've been doing this quite different models. This is a standard square wave generator, also called the relaxation oscillator. So these kind of square wave generators are used as clock for digital logic, right? So let's see one more. Now this is a very good question. Find R and C. So this is a simple low pass filter. The examiner wants you to calculate the elements R and C. And he has given a graph here. But if you carefully observe the graph here, at this is on a log scale. So at 0 frequency, the gain is maximum. At 0 frequency, the gain is maximum. So at frequency 0, you can see that 1 plus R by 1K into V in, that is the gain. So 1 plus R by 1K, this is going to be V0 by V in. But since this is on a log scale, what we have to do is 20 log A is 12. If I remember, this A is around 3.99, so I'll take it 4. So from here, you have got the answer. 1 plus R by 1K is 4, so this is 3, so your R is 3K. So the first component is done, right? And you all know simple subtraction, right? So this is 12 and this is 9. So what is 12 minus 9? So it happens to be the 3 dB down value, because 12 minus 3 is going to be 9. So at this frequency, which is, this is on a log scale, 1K, so you have the cutoff frequency. The cutoff frequency is 1K because it's the 3 dB down value. So by looking at this without finding the transfer function, we can simply say omega is 1 by RC, because this is a standard low pass filter, right? So omega is 1K. R is given as again 1K, and you have C here, right? So this C happens to be 1 microfarad. So this is a simple question, but very intelligent way of giving it, right? So by looking at the graph, I've taken 2 points here. I mean, this is 1 point I'd like to focus, and this is the second one, right? So this point would give me R, and this point would give me the value of C. But how do I calculate without the transfer function, without all the 20 log stuff? Because I know that 12 minus 9 is 3, right? So 12 minus 9 is 3. So this is a 3 dB down value. So this is obviously the cutoff frequency. So that's the viewpoint here, right? So this is a very good one. Yeah, find the ratio of minimum to maximum small signal gain. Right, see, when we change the input, remember if the diode is on, right? And then you keep changing. When you keep changing, where is the dynamics? The whole dynamics is across the resistors, but not across the diode. Because the examiner, if I remember, he has given VD on constant 0.7 volts. So by looking at this data, what comes to my mind is the diode will have 2 states, right? So what are the 2 fundamental states of a diode? One is the forward bias and the other one is the reverse bias, right? So if the diode is off or reverse bias, then your V0 by Vin, the slope is going to be a simple voltage division, right? So you know the voltage division rule. So if this is like R2 and this is R1, so you're going to have 2K plus 2K by 2K plus 2K plus 2K. So it's going to be 4 by 6 or 2 by 3. So that's the slope, right? Now what happens if the diode is on? If the diode is on, the voltage across the diode is 0.7, and when you change the input, the dynamics is only across this. So the gain would depend on the slope. The gain is nothing but the slope of the transfer characteristic. So it's going to be 2K by 2K plus 2K. So it's going to be 1 by 2. So what is the ratio of minimum to maximum? Out of these two, what is the minimum value? If I think 2 by 3 is 0.6, right? So this is 0.5. I think this is minimum and that is maximum. So minimum by maximum is 1 by 2 by 2 by 3. So that's 3 by 4. So it has to be 0.75. Now, just to give you some insight onto this problem, let me give you a small circuit here. I think you would have done circuits like this, where you have a R1 and R2 resistor, and this is your V0, right? And this is Vin. So if you try to apply the voltage division rule, the slope y equal to mx, if you try to write it, the slope will always be R2 by R1 plus R2. And what happens when you have a diode? If you have a diode, the result is the same. Say if you have R2 here and R1 here, I mean these type of problems you would have done in class, right? So when you give Vin more than 0.7, the diode is on. But after that, you keep changing your Vin, the slope or the gain will always depend on the resistors R2 by R1 plus R2. So this is a simple logic here, but of course, if you want, I mean, you can apply Kirchhoff's law and make it lengthy, right? So you can take a V0 here and you can take 0.7 here. And you can say I is Vin minus 0.7 by R1 plus R2, and then your V0 is this drop, and then get it in the form of y equal to mx plus c, and then the m is the slope. But the m is the dynamic. The dynamics is only on the resistors, because we all know that the slope only depends on the resistors, it doesn't depend on the voltage. So that's the logic here, right? Okay, so this is another problem You would have solved such questions in your digital class, right? So you would have mastered these questions in digital class. But let's look at this problem in a network way of doing it, right? So how do we solve this? So if you have a voltage divider like this, V, R and R, then the output, the Thevenin equivalent of this is going to be V by 2 in series with R by 2. I think this simple logic is enough to finish this. So you can even do by superposition theorem. So in superposition, so what if this is grounded? So this is 1.6 with a voltage divider. So I better write here 0.8 in series with R, right? And then this R and R comes in series. So if I break this guy here, it's going to be 0.4 in series with R. So if I break him here, it's going to be 0.2 in series with R. And if I break him here, it's going to be 0.1 in series with R. So that R and this 2R comes in series. So this R and 2R comes in series, so that the whole value becomes 3R. So here you have a 0.1. So this is a simple inverting amplifier, and cleverly the examiner has given 3R here. So you know why he has given 3R? Because your V0 is going to be minus 3R by 3R into 0.1, so that's minus 0.1. So with the help of this voltage, I'm getting minus 0.1. Now what if I take this voltage, right? So it is much quicker now, because the 2R and 2R is R, and this R comes in series with R, that's 2R. And this guy is again, R, and then 2R. And here, I'm going to break it, and I'll change the color of the pen. Now here, so this is 1.6, so I'm going to make it 0.8 in series with R, and this is guy is 0.4 in series with R, right? So this is 3R, so the output is going to be minus 0.4. So by superposition theorem, if I try to add them, minus 0.1 minus 0.4 is going to be minus 0.5. So this is how you can solve this. But you have the digital way of doing it also, the resolution formulas and all that stuff, right? Okay. This is all. Yeah, I think this is all. I have received one more question. I probably forgot to, I'll just write the question and finish it. Yeah, this is the last one. So in this question, the examiner has given a PMOS and an NMOS. So this is a clever way of asking. If you see, here he has given 4 volt, and the W by L's are different. The W by L is 5, and here the W by L is 1. So I'll not take much of your time. So the 4 options are excellent here. The 4 options say that, is this V0 0? Is this V0 2? Is this V0 less than 2 or greater than 2? Something like that. I don't exactly know the values, right? And he has given Kp and Kn, right? So the Kp is mu Cox W by L, and he has given Kn mu Cox W by L. So you can calculate it, but it so happens that this mu is the mu is 300, and the mu of this guy is 300, and this guy is only 40, right? But the W by L, the W by L of the upper guy, Kp, is 5. So this guy is 1. So there's a simple logic here. The logic is 40 into 5 greater than 300? 300 into 1. So you can see here that 300 into 1 is greater than 40 into 5. Because 40 into 5, you know, 5 goes 4 times 20. So this is 200, right? So this is 300. So if you remember, the actual graph goes like this between V in and V0. This is a very standard graph, you know, you study in CMOS circuits, and the graph goes like this. if this Kp and Kn both are same, then this guy is going to be half, right? So, but what happens if this Kn is much larger than Kp? If Kn is much larger than Kp, then the value is going to go near to the origin, right? So this guy is going to be less. The V naught is going to be less. So that's the logic here. But if Kp is greater than Kn, then your value is going to increase. And this is a very clever way of asking, right? So you can prove this by taking the normal ID equation, like how we do in the, you get a quadratic equation and you solve it. I mean, you can do that, right? But you can, he didn't ask you the exact values. I've tried calculating this value. This is around 1.89, but that's waste of time. So you can see here, if your Kn is greater than Kp, it means that the value is decreasing. So this value is decreasing. So hopefully less than 2 should be the answer, right? So my best wishes to you. Good luck.
Yeah, very good evening students. I am Shivasubramaniam Medisani, faculty at ACE Engineering Academy. So I am going to discuss two questions from the electronic devices. So this whatever the questions that we got from the students, okay, so we are trying to provide the solution, okay, so they may not be the exact one, okay, yeah. So let us see the first question. P-type semiconductor having hole concentration, so the value of hole concentration is given, the value is 10 power 17 per centimeter cube, okay, and he has also mentioned what is the intrinsic carrier concentration. Now it is illuminated by the source, nothing but a laser he has mentioned here at left end of the semiconductor at x equal to 0, fine. Now given the diffusion length of the electron as well as the hole, both are given, so this is for the diffusion length of the electron, which is Ln I can mention, and what about this 1 micrometer is the diffusion length of the hole, Lp we can say. Okay, now the electron density at x equal to 0 due to illumination is given. So this is nothing but the, we can call it as the excess carriers. So one of the very important topic in the semiconductor theory is the excess carriers, and this excess carriers is again a unique property of the semiconductor material. Okay, so this is going to be, yeah, these notations may change, okay, but try to concentrate. So this I will take it as, let me take it as capital delta N. Okay, then what we need to find out is the electron density at x equal to 2 micrometers is. Okay, so one second please, yeah. So what he is asking is, let me take, this is the p-type semiconductor material, okay, so this is the p-type semiconductor. Let us take, this is x is equal to 0, okay, and this is the x I am taking in this direction. So here we are illuminating at this end, we are illuminating x equal to 0 point, you are illuminating. Now we know this h in u must be at least equal to the energy gap, anyhow this is the basic requirement to generate the excess carriers, okay, or the electron hole pair, we know that, okay. Now what will happen to this concentration of excess carriers once you take with respect to the distance, let me take this is x, okay, and let me take this is the excess carriers, let me take it as delta n. So what will happen, this is going to decrease exponentially, we know very clearly, yes or no, this starts decreasing exponentially like this. And let me take this value, okay, at x equal to 0, whatever you are having, that I am going to take it as capital delta N, then I can write simply capital delta N, okay, this variation I am writing e power minus x divided by ln, as simple as that. So this value is given, x he has given it as the 2 micrometer, ln he has mentioned in the problem which is 2 micrometers, okay. So let me check the value here, that is a 10 power 14 per centimeter cube is going to be your delta n, okay. So this is 10 power 14 into e power, it's a x is equal to 2 micrometers as well as your ln, it is also 2 micrometer, so minus 2 micrometer divided by, okay. So you just calculate this value, this will give 3.678 into 10 power 13 per centimeter cube. Anyhow, in the problem he has not mentioned whether he is asking the total electron concentration or the excess electron concentration, but anyhow whether it is the total or excess electron concentration we can take this directly, because we know the total electron concentration, I can simply write it as what, n is equal to n naught plus delta n, okay, or whatever the value that we got it here, let me take it as the same notation. Okay, so this I will take it as capital delta N. So the N naught value how you can calculate, because it is given, P naught value is given, P naught is how much, 10 power 17 per centimeter cube, Ni is also given which is 10 power 10 per centimeter cube, okay. So I can write now this N naught value, what is this N naught value, you can get it, this N naught value is going to be 10 power 3 per centimeter cube. You just apply the mass action law, P naught into N naught is Ni square, okay, then it will be 10 power 3, and this value is this one, 3 point, this value is this. So approximately now you can simply write it as 3.68 into 10 power 13 per centimeter cube. So it may be total electron concentration at x is equal to 2 micrometers, or it can be taken as the excess carriers at x equal to 2 micrometers. It's a very simple and straightforward questions that we usually discuss in the class. Fine, okay. Let us solve one more question. So this is based on the mass capacitor, so which is a very important topic, okay. If you see your previous gate examination around 4 to 5 years, okay, this topic is going to be very important, okay, and it's going to be very simple also, whatever. Let us see the question. An ideal mass capacitor, anyhow the substrate is the p-type semiconductor is shown in figure. The mass capacitor is under strong inversion. Hope you know what is meant by strong inversion. Now the gate voltage that I am applying here, okay, I am applying the gate voltage of how much? 2 volts, fine. The corresponding inversion charge is given, which is 2.2 microcoulomb per, I think it is centimeter square, yeah, it is centimeter square, okay, fine. Then what is given? Assume oxide capacitance value, Cox is given, very good. For Vg is equal to 4 volts, he has changed the gate voltage now, Vg is 4 volts now, fine. What you need to calculate is what is the inversion charge, okay, in microfarad per centimeter square, round to 1 decimal. So just straightforward, what it is, we know the inversion charge is equal to minus Cox into Vg minus Vt. Yeah, again this minus and plus you have always a lot of confusion. Please remember the equation is not having any intelligence, but okay, you have intelligence whether you can decide the plus or minus. When you have the p-type substrate, what is the inversion charge you are going to have? It is going to be the electrons, nothing but the negative charge, okay. So based on that we can do, or if you have any confusion you take simply the magnitude and you can find out, there is no problem with that, okay. Now so based on this what you can do is, he has given what is the Cox value and this value is also given and this is given. You can get the threshold voltage and then for the next one you can substitute that and you can calculate. Other than that it is a very simple way that I can calculate. Let me take, this is for the one gate value, okay, Cox is the same. Now Vg1 minus Vt you can write, let me take it as equation 1. Now you are changing the gate voltage, correspondingly the inversion charge also changes. So Cox into what it is, Vg2 minus Vt, let us take it as equation 2, fine. So you just take it as 2 minus 1, okay. So what I am going to get, this is your left hand side, okay, yeah, sorry I have forgotten the minus sign here, let me write. So it is minus Cox into what, Vg2 minus Vg1, you just subtract 1 from 2, this is what you are going to get. And while substituting the values be careful, okay. So what he has mentioned, what you need to calculate is this Q inversion of 2, okay, inversion charge for the second case you have to get it. This is given in the problem, which is 2.2 microcoulombs per centimeter square, and it is minus, please, okay. So minus 2.2 microcoulomb per centimeter square is going to be equal to minus Cox value, what is the Cox value given, 1.7 microfarad, okay, per centimeter square, 1.7 microfarad per centimeter square, okay, and Vg2 is 4 and this will be 2. So what I am going to get now, for the second case, okay, now you take this to the other side, again it will be minus 2.2 microcoulomb per centimeter square. What about here, 4 minus 2 is 2, 2 into 1.7, 3.4 and the minus sign, so 3.4 microcoulomb per centimeter square. So what I am going to get, minus 5.6 microcoulomb per centimeter square is the answer. So you can take 5.6 is the answer. Okay. Yeah, here you can do first, you can calculate the threshold voltage, then you can substitute. That is one way of doing, but I think this is the simplest way that you can do. But again I am telling you, whenever you are writing the equation, be careful, okay, because if you understand the concept, then you will have the clarity. Otherwise what you people can do is, suppose in this, if you substitute instead of minus 2.2 microcoulomb per centimeter square as 2.2, you are going to get a wrong answer. Okay, because when I say when you have the p-type substrate, obviously the inversion charge is going to be the negative. So be careful with the signs. So equation don't have the intelligence, but you have the intelligence. Okay, so once you have the concept, clear understanding of the concept, then you can do these things. Okay, yeah. Now I'll hand over the session to the Srikanth sir. He will discuss about signals and systems. Thank you.
Hi my dear students, myself S. Srikanth, faculty at ACE Engineering Academy, teaching signals and systems subject. So let us see the questions which are asked in today's GATE exam. This is the weightage of signals and system subject asked in today's GATE exam. See the analysis. From the LTA system chapter, one mark question was asked. From Fourier transform chapter, 2 marks questions. From Laplace transform chapter, 1 2 marks question. From DFT, 1 2 marks question. So total 9 marks asked from the signals and system subject. So let us see the questions. Before starting the questions, see whatever the questions we are I am discussing now, all are memory based questions. There may be little bit deviation from the exact question. Okay? Yes. See the first question. Find the Fourier transform of x of t equal to t by 1 plus t square whole square. See, to solve this problem, you have to know the standard Fourier transform pair, that is e to the power of minus a mod t. Fourier transform is 2a divided by a square plus omega square. So let us substitute a equal to 1 here, then e to the power of minus mod t Fourier transform is 2 by 1 plus omega square. Why I have substituted 1 here? Because you see here 1 plus t square is there. For that reason I have substituted 1. But you see here in the problem it is whole square is there. So how to get whole square? So multiplication in time domain results differentiation in the frequency domain. From that property, if I multiplied with t, then t e power minus mod t Fourier transform is j
d by d omega of 2 divided by 1 plus omega square. So it is multiplication of t in time domain property. So from this, tell me students, t e to the power of minus t Fourier transform is, tell me what is the differentiation of this? J into minus 2 by 1 plus omega, j into minus 2 divided by 1 plus omega square whole square. Again, the differentiation of 1 plus omega square is 2 omega. So t e to the power of minus mod t Fourier transform is minus 4j omega by 1 plus omega square whole square. But in the exam, they have asked this quantity in time domain. So how to get it into time domain? Apply duality property. You know duality property statement. If I can write this quantity here, but replace omega with t, then minus 4j t by 1 plus t square whole square. Fourier transform is, you can write this quantity here, but multiply with 2 pi and replace t with minus omega. 2 pi minus omega e to the power of minus mod of minus omega is mod omega again. So I want only t by 1 plus t square whole square on the LHS side, then t divided by 1 plus t square whole square. Fourier transform is, see students here, send minus 4j that side, then 2 pi by minus 4j, 2 pi divided by minus 4j into minus omega into e to the power of minus mod omega. See here, 2 pi divided by minus 4j minus omega into e power minus mod omega. So now the Fourier transform is going to be minus into minus plus. So pi divided by 2j. Pi divided by 2j into omega into e to the power of minus mod omega. 2 1 ja, 2 2 ja, so pi by 2j into omega into e to the power of minus mod omega. So this is the Fourier transform for the given signal. Okay students? Yes. So I can say that it is a moderate question. Okay? Yes. Now see the second question. This question is related to, I can say that it is a combination of LTI system and Laplace transform. The question is x1 of t equal to e power minus t u of t and x2 of t equal to u of t minus u of t minus 2 and y of t is x1 of t convolution x2 of t, then the value of y of infinity is how much? This is asked for 2 marks. See students, apply Laplace transform to this quantity, then convolution in time domain equal to multiplication in the Laplace domain. So x1 of s into x2 of s. Okay, now tell me students here, y of s equal to, what is the Laplace of e power minus t u of t? 1 divided by s plus 1 into, what is the Laplace of u of t minus u of t minus 2? 1 minus e to the power of minus 2s divided by s. So finally, how much y of s I got, tell me? Y of s equal to 1 minus e to the power of minus 2s divided by s into s plus 2. S into s plus 2. Now, he is asking the quantity y of infinity. Y of infinity. Now, you can apply inverse Laplace transform and substitute t equal to infinity, or you can apply final value theorem also. Let us see students whether we can apply final value theorem or not. One pole is located at origin, one pole is located on the LHS left side of the S-plane. Yes, I can apply final value theorem. So you apply final value theorem. What is the final value theorem statement? Limit s tending to 0, s into y of s. So this is equals to limit s tending to 0, s cancel, then 1 minus e to the power of minus 2s divided by s plus 2. This is equals to 1 minus e power 0 is 1 divided by 0 plus 2. 1 minus 1, 0, 0 divided by 2, that equal to 0. So what is the value of y of infinity? 0. Okay students? Yes. So it is a easy question. Okay? Yes. Next, see the next question. Yes. So every time we are telling in the class from DFT chapter, every year they are asking 1 2 marks question. So this year also they have asked 1 2 marks question from the DFT chapter. The question is 8-point DFT of x of n equal to 1 0 0 0 2 0 0 is capital X of k. X of n 8-point DFT is x of k. Then he is asking an information given as y of n equal to dft of x of n, then the value of y of 0. If you don't know the simple logic, it will take 2-page solution. If you know the simple logic, you can solve it within half minute. See, what is the logic? What is the information given? Y of n equal to dft of x of n. Here you have to apply a simple logic. What is the dft of x of n is y of n equal to capital N into x of minus n modulo n. This is the logic. If I apply 2 times dft to a sequence, it's going to be n into x of minus n modulo n. What is the sequence given? 1 0 0 2 0 0. If I apply time reversal operation, that is x of minus n modulo n to that, again you will get the same sequence. So x of minus n modulo n is also going to be same 1 0 0 2 0 0. Okay? Yes. What is capital N value? 8 point dft given. So y of n equal to 8 into that one. So 8 0 0 16 0 0. He is asking what is the value of y of 0. First element. What is the value of y of 0? 8. Yes. If you know this logic, see how it is going to be easy. If you don't know this logic, it's almost all half an hour time. Okay? Yes. So this is 2 marks question. See the one more question. Which of the following system is an LTA system? This question asked for 1 mark. It is LTA system chapter question. See what is the question is. This is the input, this is the output. Okay, which one is the LTA system? Sin t, sin 2t. 2t is there. So it is a linear but time variant system. And sin t plus 1. It is linear and time invariant. And sin t, sin square t. So it is square operation is there. So it is non-linear and time invariant. And the last one, sin t, sin minus t. So it is linear and time variant. But there is some small, see here, sin t, sin minus t. I can write sin minus t as minus sin t, means 180 degrees phase shift. So if I cascade 2 Hilbert transforms, I will get 180 degrees phase shift. So 2 Hilbert transform, you know that Hilbert transform is a LTA system. Cascading of 2 LTA system is a LTA system. So there is some, if you know the exact data, I can say that whether D is a LTA system or not, because here this question is based on the student memory based. So which of the following system is an LTA system? Suppose which of the following system could be an LTA system, can be an LTA system. If I know that exact data, I can say, I can talk about D option. So after receiving the exact question paper, we'll decide on D option. But up to now, B is the linear and time invariant system. Okay, students? Yes. And see one more question. This also, I have received only 50% of the information. What is the question is, this is the frequency response of the system is given. And S1 data I have not received exactly. That's why I'm leaving it as empty. He's asking that S2 is power spectral density of the output equal to power spectral density of input for mod f less than f1. Yes, we know it is a standard formula. What is the formula? Sy of f equal to Sx of f into mod h of f whole square. So what is h of f given? 1 for mod f less than f1. Yes, so if I apply that, Sy of f equal to 1 into Sx of f. So Sx of f for mod f less than f1. Yes, statement 2 is correct. But statement 1, we have not received the exact information. I am leaving that empty. Okay, yes. So these are the 5 questions they have asked from signals and systems. I hope you have attempted the exam very well. All the best, students. Yes.
Okay, welcome back friends. Let us deal with some questions which are related to the communication. Here is a question, I'll just read out. Consider FM broadcast that employs a pre-emphasis filter with a frequency response this one. Here it is the 1 plus. Actually, the pre-emphasis filter transfer function is 1 plus j omega by omega naught. That omega naught value is provided as 10 to the power of 4 radian per second. For the network shown in the figure, okay, acts as a corresponding de-emphasis filter, then the R and C values are. So as we all know, the pre-emphasis and de-emphasis techniques are employed in the FM modulation scheme. In the transmission mode, we'll going to increase the signal strength of the high frequencies, and at the receiver, we're going to decrease the signal strength of the high frequencies. That is called pre-emphasis and de-emphasis. Fine. So there is a condition and there is a relation between the pre-emphasis and de-emphasis transfer functions of a circuits. If you remember, the pre-emphasis, I'll just represent it as a HP, into de-emphasis, magnitude of the pre-emphasis and de-emphasis. Magnitude of the transfer function of the magnitude of the pre-emphasis and de-emphasis must be equal to constant. I'll make this as a 1 here. Clear? Yes. So this is a de-emphasis circuit is already provided in the question. Fine. So this is the output, this is the input here. You are giving the input, received signal as an input here. Fine. So now what I'll do here, I'll just find out the de-emphasis transfer function and I'll multiply that one with the pre-emphasis. That I'll equate it to the constant, or I'll take it as a 1 here to make the thing simple. From there I may get a omega naught value. Yes. So from there I'll get some R and C values for the design. Fine. So what is the transfer function of this one? Output by this one plus this one. So what is the H output HD transfer function is equal to 1 by j omega divided by plus 1 by j omega. Omega C. Let me correct myself. Fine. So HD here, de-emphasis transfer function of the de-emphasis circuit is equal to, you can check out, 1 plus R by 1 plus j omega RC. Okay. You can find out the magnitude of this one and you can find out the magnitude of this one, multiply those two things and equate it to 1. Fine. So let me turn the page here. So what is the free emphasis circuit magnitude? Magnitude of the free emphasis circuit into magnitude of the transfer function of the de-emphasis circuit, which is equal to, let me go back. How much is this? The magnitude of this one is square root of 1 plus. Just I'll take only the magnitude square. Fine. So which is equal to 1 plus omega by omega naught whole square into transfer function magnitude square I'll take. Fine. So what is the magnitude square? 1 by square root. I'll just leave the square root. I'll take the magnitude square. So here it is 1 plus. That means I'm taking the square here, nothing wrong. So here it is 1 by 1 plus omega RC square. That must be equal to some constant. I'll make that one equal to the 1. Fine. You can do the comparison here. So this will be equal to the constant. If you consider the magnitude of the transfer function here, some constant k naught here, some constant k naught here, there will be some constant. Just I'm taking only the normalized values. That means I'm interested only in the nature of the transfer function. Clear? Fine. So this part must be equal to this part. Then only it will become 1. Clear? Very straightforward. Without going into the detailed discussion of the analytical approach of solving this equation. So omega by omega naught must be equal to omega RC. Clear? Fine. So omega naught, omega cancel out. So omega naught is equal to R into C. Done. So R into C is equal to 1 by omega naught. So the omega naught value is provided here as 10 to the power of minus 4 actually. Here it is. Let me check out this value properly. It is 10 to the power of 4. Yes, it is 10 to the power of 4. It is 1 by 10 to the power of 4. So R into C is equal to 10 to the power of minus 4. So you have got a R into C value. You can cross check from the options here. Fine. So let me go back here. So option A will be best suited for this one. It is option A is a 1 kilo and 0.6 micro, 0.1 micro. You can take the product of these two things, that will be equal to the 10 to the power of minus 4. Fine. So the logic here is the pre-emphasis and de-emphasis circuits, the property, the design formula for the pre-emphasis and de-emphasis. Fine. Okay, very simple. The concept, the simple concept is taken from your communication, that in the FM modulation scheme we are using what is called a pre-emphasis, analog communication scheme. That is combined with the transfer function concept here. Fine. And there is a RC circuits also involved. Too many concepts are involved. Fine. Okay. Let us take one more question here, something related to the bit rate. Yes, here is a question. Yes. A symbol stream contains an alternative QPSK and 16 QAM symbols. If the symbols from this stream are transmitted at a rate of 1 mega symbols per second, that means it is a symbol rate. The raw data rate is. Here the two modulation schemes are transmitted alternatively. Fine. So we know from our formulas that how do you find out the symbol rate or bit rate, sorry. The bit rate formula is bit rate is equal to symbol rate into n value, isn't it? Small n value. These are the small n, capital M values are the standard representations. Okay. So here you can write it as a log of M. But here there are two modulation schemes. Fine. Let us deal with the first one here, QPSK. Here the M value is equal to 4 and obviously N value is equal to 2. Clear? Because M is equal to 2 to the power of N. Fine. So all these are known for us. So what is the rate here? I'll call it as a RB1, which is equal to, what is the symbol rate is 1 mega. 1 mega into N is 2. So here it is 2 mega bits per second. Done. Okay. Similarly, you can do the same thing with this 16 QAM. Fine. So here number 2, 16 QAM. Here M is equal to 16 and N is equal to 4. Fine. So here it is RB2. RB2 remains the same. Symbol rate into N value. N value is 4 here. The symbol rate is 1 mega. So 1 into 4. Here it is 4 mega bits per second. Done. But then what is the bit rate I should consider? Should I consider this one or this one? But he said here in the question, it said they are sent, those two modulation schemes are sent alternatively. So what I'll think is, they must be with the equal probable, isn't it? So if they are equal, if the equal probable, nothing is mentioned regarding that. So I'll assume that it as a average. Yes, I'll take the average bit rate. Yes, if nothing is mentioned, they are said alternatively. If the one first QPSK, then 16 QAM, and then this one and this one alternatively. Fine. So I'll take the average here. I'll assume those two things as a equiprobable, isn't it? That is what generally we'll do if probability of something is not given. We'll assume it as a equiprobable. Yes. So what is the bit rate here? RB. We'll take the average of these two things. So here it is 2 megabits per second plus 4 megabits per second divided by 2. Fine. So RB is equal to 3 megabits per second is the answer. Okay. These are the two questions, very interesting question. I need to discuss some more questions which are related to the communication, but let me hand over the session to the other faculty.
Come back, dear students. There is a small technical glitch, it's okay. Students, let's come back with another numerical of analog circuits. So this is the circuit they have provided as per the data we got from the students, dear students. Like an ideal op-amp circuit with a sinusoidal input is shown. That is a pure sinusoidal frequencies they have provided, fine. If you check it out, the 4 options, the 3 dB frequency is okay. That means it is giving a hint that we can find some 3 dB frequency. So no doubt, examiner expecting a filter response, fine, that is fine. The circuit is a low pass filter, interesting. The 3 dB frequency is 100 by 3 radian per seconds, and option D, the circuit is high pass filter. I believe this must be a 1 mark question, right? Okay, and it must be a multiple select questions, I believe. It is very easy, dear students. I think you need not to find the transfer function. Let us verify the methodology what I have discussed in the class, time saving techniques, because here I need not to find the magnitude of the voltage gain, correct or not. So let us find whether it is like a low pass filter or high pass filter. The same circuit, if I consider here the same circuit, let me check it out as per our strategy, dear students. Consider at f is equals to 0. Consider at f is equals to 0. We know that XC is equals to 1 by omega c. So XC is 1 by omega c, f is equals to 0, no doubt the reactance will act as infinite. So what it shows, dear students, this capacitor will act as open switch. So whenever this capacitor will act as open switch, there will be no output. So there doesn't exist V naught, because it is an ideal op amp, okay? So there doesn't exist V naught, no need to discuss anything about V naught, and the gain could be 0, right? At f is equals to 0 hertz. In the similar way, the second test, what we are supposed to go at f is equals to infinite, take it as infinite, higher frequencies. No doubt, XC 1 by omega c will act as what, dear students? 0. Whenever the reactance act as 0 over here, no doubt the capacitance will act as what, dear students? Short circuit. Whenever capacitance is short, no doubt there exists a gain. Correct or not, dear students? That means what? There exists V naught and there exists gain. Now tell me, dear students, at low frequencies, no gain. At high frequencies, gain exists. What it represent? High pass filter. So very clear, it is behaving like an high pass filter. So as per the given options, yes, the circuit is behaving like a high pass filter. That must be correct answer. But I can't omit this because he's asking about 3 dB frequency also in one of the options. Let me verify the 3 dB frequency. Again, the simple method, assume this capacitance as the load, because with reference to the capacitance, we are supposed to find the frequency. So dear students, how can we proceed here? So take as simple as like a Thevenin's load here. Do one thing, like find with reference to the capacitor, find RTH. And this is like short. And here we have the resistor 1K. The same method, because I have solved a lot of questions in the class to find the cutoff frequencies or 3 dB frequencies from this circuit analysis. Correct or not, dear students? So here we have inverting, non-inverting, this is ground, and this is negative feedback. So V naught. So here it is 2K. No doubt this voltage will become 0 volt. So it is like a virtual ground, or we say virtual short. So as simple as RTH value would be how much, my dear students? Like 1K. So what could be the cutoff frequency, or we say 3 dB frequency here? F is equals to 1 by 2 pi RTH into C, because only one capacitance we have, no need to find C equivalent, just only C. So here asking radians per second, therefore, so omega 3 dB is nothing but 1 by RTH into C. That RTH is nothing but 1K. So 1K into, this is 1 micro. So 1 by 10 power minus 3. So itself represent 1000 radians per second. Correct, dear students? My goodness, 1000 radians per second. So I believe option A is also correct for this given numerical. Therefore, option A and option D. So if the given data is correct, then option A and option D must be the answer for this given question. So it must be a multiple select question. And let me do one numerical from electronic devices. Is it okay? Of course, very simple numericals. So electronic devices, yeah, go with this numerical. The previous questions other professor has covered already, you have seen that, right? So check it out this question, dear students. The ideal long NMOS and PMOS devices. Yes, these two devices they have provided. Believe you know that. This is a simple NMOS, and here with reference to the PMOS, because with respect to the gate, there is a knob provided or bubble provided. That is under the digital terminology. We take this as what, dear students? PMOS, and that is like NMOS, you know that, logic gates. Now students, here, you please let me know. So the threshold voltage for NMOS provided as 1 volt, the threshold voltage for PMOS provided as -1 volt. Now ignore the leakage currents, fine, okay. Assume that the capacitors are initially having no charge, then the applied voltage is shown, then the steady state voltages, that is the steady state voltages at V1 as well as V2 we are supposed to find. Very simple answer. Student, this is NMOS, so this is PMOS. NMOS, I believe you could recollect that it cannot pass strong 1. You know that there are two variables like logic 0, logic 1, strong 1, weak 1, strong 0, weak 0. Correct or not, dear students? So this is the NMOS. Original behavior of NMOS, it could pass weak 0, but it can't pass strong 1, correct? In the similar way, PMOS could pass strong 0, but can't pass, PMOS could pass strong 1, but can't pass strong 0, correct or not? So you please interrelate that. So here, this could be taken as what, dear students? This is the drain, and this could be what, dear? The source, because current always move from drain to source with reference to the NMOS. Now tell me, dear students, if I want to on the device, first of all, because I'm supposed to find V1, device should be on first, right? Whether it is saturation or linear secondary, it should be on first. Then only you can use it as a switch or any sort of linear applications. So for consider like M1, that is, I take it as M1 guys, like NMOS. If I want to on the NMOS, a minimum gate to source voltage must be a threshold voltage. That means at least VGS1 need to be equated to the threshold voltage. Minimum voltage we are supposed to provide at least, right? Then okay, whether it will be saturation linear, that is secondary case. Now what it could be, dear, like VG1 minus VS1 equals to VTN, because it is NMOS, right? So what is VG1? 5 volt minus, what is VS1? What we are supposed to find equals to the threshold voltage. I believe it is 1 volt. So it is very clear, guys, V1 is nothing but 4 volt. So I believe you understood. The input is a logic 1, strong 1, I say 5 volt. But output I got it as like if I take output over here, I got it as 4 volt, which is weak 1. Weak logic 1, it is not strong logic 1. That is the basic principle of your NMOS. In the similar way, PMOS, it is very easy, guys. You need not to do that, because the gate voltage what they're providing, making the PMOS to be biased. It should be on. If the PMOS is on, at default, it should be propagating the strong 1. And the input which is given to the drain, that itself is a logic 1, which is a strong 1. So the same strong 1 need to get propagated, because this is the only direction where capacitor need to get charged. Capacitor can't be charged with reference to the ground, right? This is the only direction we are supposed to accept the capacitor charging phenomenon. Either it is PMOS or it is NMOS. So the strong 1 need to get propagated. So happy to say that V2 is equals to plus 5 volt. That's it, guys, which is nothing but logic 1. So if they're asking, I don't know whether they have given options or not, because this is the data from the students, okay, what we got. If they give options, then V1 must be equals to 4 volt, V2 must be equals to 5 volt, should be the correct answer if this data is valid. Is it okay, dear students? So anyways, thank you so much. I'll hand over to other professor. Just rock in the future, guys. May God bless you.
Hi friends, welcome back. See here, there is one question for something related to the properties of the entropy. Fine. See, you can just read out, it was asked for 1 mark. These are the properties. Fine. So this is something related to the extension of the source. The remaining properties are there. From the properties directly you can answer option D as an answer. Yes. H of x, the entropy of the discrete random variable x, taking the k possible distinct real values. The true statement is option D. You can check out from the properties. Very simple and straightforward. Fine. So let us deal with something other question. Related to the discrete channel. Something. You should have some patience to deal with this question. Time taking. And it will going to test your patience. Fine. So read this question carefully. Get the things properly. It takes some time. A transition diagram of a discrete memoryless channel with the 3 input symbols and the 3 output symbols is shown in the figure. The transition probabilities are as marked as alpha in the interval 0.2 to 0.25 to 1. The value of alpha for which the capacity of the channel is maximum. Fine. So this is a channel given. So here you can call this as x1, x2, x3, y1, y2, y3. Fine. Okay. So here it is alpha minus 1. Here it is the transition probability is alpha. Here it is 1 minus alpha. Here it is alpha. Here it is alpha. Here it is 1 minus alpha. Fine. So I am going to call this as a x1, x2, x3. Standard representation this is, right. So here it is input x1, x2, x3. Here it is y1, y2 and then y3. Clear? Okay. So what is asking? Capacity of the channel is maximum actually it is maximum. Fine. So what is the channel capacity? According to the information theory, the channel capacity is equal to, the channel capacity in general is equal to a mutual information, maximum of mutual information, isn't it? That is the general definition of the channel capacity. There is a general definition, but what actually is asking is a alpha value. You have to obtain the alpha value such that, alpha is a transition probability here. You have to obtain the alpha value such that the channel capacity is maximum. Is not asking this one, isn't it? Don't get confused yourself. So what you need to do here is you need to find out the channel capacity and you need to differentiate this one with respect to alpha and make that one equal to 0. Fine. So you need to find out the mutual information here then. How do you find out the mutual information? There are different expressions for the mutual information, right? Let me turn the page here. What is the mutual information is, you can find out the mutual information with the different ways. I of x comma y is equal to h of x minus h of x given y. The other expression is h of y minus h of y given x. There is one more thing, h of x plus h of y minus h of x comma y. I am comfortable with this one. You can go with any one of this one. I will go with this one. Okay, I will find out the mutual information with this expression. Fine. Then how do you find out this h of x comma t? By definition, h of x comma t is equal to summation of for all values of I, summation of for all values of j, p of xi comma y of j into logarithm of base 2 1 by 2 into p of xi comma yi yj. Done? Yes? Then how do you find out p of x comma y? There is a relation again. P of x is equal to, you can write this one as, just a minute, p of x comma y is equal to p of x into p of y given x. You can obtain from here. Okay. So let me go back here. He has not mentioned anything regarding the probability of the source symbols, isn't it? I'll consider it as equiprobable, isn't it? That is a popular assumption what we'll make in the digital communication. So I'll do the same here. Fine. So here it is 1 by 3, 1 by 3, 1 by 3. Done? Yes, here also 1 by 3, 1 by 3, 1 by 3. So what happens to this part here? This part is a 1 by 3. That means what is P of x comma t? It is a 1 by 3 into P of y given x. Fine. Let me turn the page here. Lengthy approach this one, h of x comma y is equal to, you can use the minus 1 by 2 minus of 1 by 3. Yes, let me go back. Why? Because what is the probability of this one? P of x comma y, 1 by 3 into, let me go back, here it is 1 by 3 into 1 minus alpha. Yes, 1 by 3 into 1 minus alpha into logarithm of base 2 into 1 minus alpha minus 1 by 3 into, yes, this one. What is this one? Here it is alpha. Fine. Yes. So here it is alpha. That means here it is alpha into log base 2 of alpha. You can guess the same thing here. Because of this input, you have considered the output here and output here. And you will find the same scenario with the remaining two inputs also, isn't it? So if you give the input at x, second one, this is x2, you are going to get the output here and output here, the same scenario. Alpha, fortunately the alpha is same, isn't it? So what does that mean is, you no need to do for the input x2 and you no need to do for the input x3. Just you can multiply with the number 3. Fine? Okay? There is some kind of symmetry here that will going to save our time. Fine? That is how the question is designed. So you can just multiply, because this is a summation, right? You can multiply with the number 3. Clear? Okay? Fine. So what happens to the h of x comma y is equal to minus 1 minus alpha into log of base 2 1 minus alpha minus alpha into log of base 2 into x. Done? Fine. So you have got h of x comma y. So you can find out here h of x plus h of y. What is h of x and h of y? I have taken it as a equiprobable, isn't it? If they are equiprobable, what happens? It is 1 by 3 with the probability 1 by 3. So you are going to get 3 into, right? Yes. So what you are going to get here, h of x is equal to, you can, if you want, you can directly write down h of x is equal to, or otherwise I will directly write down h of x comma y is equal to h of x plus h of y minus h of x comma y. Done? So what is this h of x? They are equiprobable I have taken. 2 into, isn't it? Sorry, 3 into 1 by 3 into, isn't it? I have taken this as equiprobable. So what is the entropy of the input source? It is natural, logarithm of base 2 into 3. Fine. And I am taking the output as also equiprobable here. Equiprobable. 1 by 3, 1 by 3, 1 by 3. Fine. So if that is a scenario, what happens to this one? You can directly guess from here. So what is the, if they are equiprobable, it is log base 2 of 3 plus log base 2 of 3 minus, already there is a minus here, so it will become plus. So it is 1 minus alpha into log base 2 1 minus alpha plus alpha into log base 2 into alpha. So what is the condition here? This is for the maximum. We have considered the equiprobable. Obviously, it will going to offer the maximum mutual information, that is the channel capacity. But what is the question here? The question here is asking for what value of alpha you will going to get the maximum channel capacity. So what you need to do? Obviously, I need to differentiate this one with respect to alpha, and I should make that one equal to 0. Clear? Lengthy thing. There is no other way. This is only the thing you need to deal with this one. So you can call this as a C, or you can just equate this one to the, with respect to the alpha, d by d alpha of I of x comma y, and I should equate this one to 0. So I'll take a liberty to do this one. I'll leave this differentiation to you. Fine? Okay. Now if you differentiate really this part, what you're going to get is, interestingly, you're going to get 1 minus alpha divided by 3, which is equal to alpha by 3. So here it is 1 minus alpha is equal to alpha. Alpha is equal to 1 by 2. So alpha is equal to 0.5. But unfortunately, this is not the answer. As I said earlier, this is a test for your patience, isn't it? That is how this question is designed. You need to cross check this one, isn't it? When you would have learnt in your mathematics, when you differentiate some function and make that one equal to 0, it may give the maximum value as well as the minimum value as well, isn't it? So it is giving the minimum value here. How can you cross check that one? Again, you need to one more time differentiation. Clear? Yes? If you one more time differentiate that one, that means you need to differentiate this function one more time. I leave that one to you. It is just a differentiation, it is just algebra. Okay? So I'll leave that one to you, that differentiation to you, and that will be equal to greater than 1. So that means if I do one more time differentiation, I of x comma y divided by alpha square, this will be greater than 0. So what does that mean? If this is greater than 0, whatever the value you got, that is contributing for the minimum value of the channel capacity. But what is required is a maximum value, isn't it? So what I need to do then? Yes, they have got a solution here. You need to plot this one again. Just a minute. To plot this one again for the maximum value, yes. So, and there is a range is provided here, yes. You can check, that is why in the question the range is provided. Let me go back, further go back, yes. So the alpha range is provided from 0.25 to 1, isn't it? So for the maximum value, so what you have obtained is the minimum value. That is contributing for the minimum value of the channel capacity. So alpha value must be in the range 0.25 to 1. Yes, let me go back here. If you consider the alpha value as a 1 in this one, if you consider the alpha value as a 0.5, you will get the minimum value, isn't it? Suppose if you consider in that range, alpha value as a 1, immediately you can check from here. Suppose if you take alpha value as a 1, from this expression you can check out. Because that is what the range is provided in the question itself, isn't it? Suppose if I consider the alpha value as a 1, so this part is 0, this part is 1, but natural log of 1, it is 0. So this part is 0, you are going to get a maximum value for this one. Yes, so from here don't fall into the mathematics, just you can decide the answer from here. Fine. So what must be the for maximum value of channel capacity, alpha value must be, so how you are deciding this alpha value as a 1? By substituting that 1 in the channel capacity expression. Otherwise this would be, again you need to solve this one analytically. Fine. So as the range is given, this will going to save our time. No doubt, undoubtedly it is a very lengthy thing, because we'll be happy as soon as you'll get the alpha value, we'll be happy with this 0.5, isn't it? Again you need to cross check this one, again one more time differentiation is also needed. Fine, okay. So two differentiation I left to you, please cross check that one. Fine, okay. So because of the some time constraint, okay, let me deal with the one more question. Fine, okay, fine. There is a one more question here, which is related to the probability of error. It is related to the maximum likelihood question. ML detector. ML. Okay. Consider the channel over which the either symbol. Let me cross check this question if it is properly typed. Just a second. Yes. Consider the channel over which either the symbol X of A or a symbol XB are transmitted. Okay. Let the output of the channel is Y be the input to a maximum likelihood detector, okay, receiver. The conditional probability density functions for the given Y and X of A and X of B are. So if you want me to write them properly, this is the thing actually. They are not properly printed. So here it is f of, let me write down here. F of, here it is f of y probability of the symbol y for a given xa is equal to this one. Just a minute. Let me turn the page, the space is not sufficient here. So there are two probabilities are given. F of y for given x with respect to function of y is equal to f of y for given x, symbol b function of y. There are two probability functions are provided here. Very simple, e to the power of minus y plus e to the power of minus y plus 1 into u of y plus 1. Fine. This one, e to the power of y minus 1. Let me cross check this one. Yes, y minus 1 into e to the power of y minus 1 into 1 minus u of y minus 1. 1 minus u of y minus 1. So let me draw these signals. From there you will get some idea. These are the probability density functions. Fine. So from the maximum likelihood condition, ML condition, what we will do, we will take the common point as a threshold. From there we are going to decide the probability error, probability of error. Fine. So we are going to do the same thing here. Fine. So let me draw some rough diagrams here. From there we will get some idea. So you are familiar with the signals and systems. So I'll assume you know. These are the very simple signals to draw. Fine. So here is the thing. Yes. So this is starting from the minus 1, right? And it is a exponentially decaying function. So what happens? You are going to get like this. Here is the thing. Clear? Fine. So here it is a minus 1. Fine. And let me draw the one more thing on the same thing, isn't it? Fine. So this is starting from, yes, this is starting, this will be starting from the 1. Fine. So how it would be? It would be something like this. Somewhere here. I am drawing the same thing. Yes. There is an intersection point here. There is a common point. We will call it as a threshold point for the ML decoding. Fine. Okay. So here it is. Then what is the threshold here? Obviously, as it is symmetric, so here it is 0. V threshold is equal to 0. Fine. So what is this one? Here it is. F of y for given a of x for given y. This is Fy for given x symbol b, it is y. So what is for ML condition, how do you find out the probability of error? Yes, you will take something like a probability of error is equal to 1 by 2 of this symbol probability of error and that symbol probability of error. There are two symbols here for given y given for xa plus 1 by 2 into probability of error for y given for xb. They are symmetrical, isn't it? You can just perform one integral and you can multiply with the number 2. Fine, but let me do this integration. So how do you find out the probability from the probability density function? You will multiply, you perform the integration appropriately, isn't it? There is a threshold here. So how you need to take? You need to take from 0 to infinity and minus infinite to 0. Fine. Okay, let me do the integration properly. Let me turn the page here. So the probability of error is equal to 1 by 2 into, yes, let me go back. Let me use the limits properly. Here it is from where? This one, yellow one. That means for the symbol, this one. Yes, this is from minus infinite to 0. Fine, is that correct? Let me cross check once. Yes, it is from minus infinite to 0. Yes, let me turn the page. Probability of error is equal to 1 by 2 into, yes, it is from minus infinite to 0. E to the power of, what is that? E to the power of 1 minus, y minus 1. Y minus 1 into dy. Plus 1 by 2 into we have taken the threshold at 0, isn't it? Common point. So it is from 0 to infinite. So here it is from 0 to infinity. It is, what is that probability density function is given? That one. Minus y plus 1 into dy. It is a regular integral, isn't it? You are familiar with these kind of integrals in your signals and systems. Fine. So 1 by 2 into e to the power of minus 1 outside. Fine. So what is this one? E to the power of y, limits are from minus infinite to 0 plus 1 by 2 into e to the power of minus 1. Here it is e to the power of minus y divided by minus 1. Integral is from 0 to infinite. This is from, this will become 1, this will become 1. You are familiar with these kind of integrals. So probability of error is equal to 1 by e. Check out this value. What is that 1 by e value? Very popular value. It is 0.367. So here we have used the ML technique. Concept remains the same, isn't it? The probability of errors also, just if you do graphically, that would be more convenient for us. If you draw them, probability density functions, what you can do, you can easily decide the threshold point. From there, you have to perform the integration. Fine, okay. So there is one irritating question that is related to the this one. What just now we have solved, something related to the maximum capacity, isn't it? Fine. And there is one more question also there, which is related to the Hamming code. I didn't have any clarity regarding that one, so that is the reason why I have not incorporated that question into this session. Fine. Okay. So I'll hand over this session to our senior most faculty, Dr. Chakrapani sir. Thank you.
let's complete the remaining questions on digital. So this is one of the state diagram given, and he asks which of the following is true. It is a multiple select question we need to understand here. So I think it's a very simple one. You know, from any state, whatever output branches it is going, the sum of transition probabilities should be equal to 1. So from some states, 3 branches will go out. From some states, only 2 branches will go out. The sum of transition probabilities should be equal to 1. Okay, so if you look at for state A, it is having 3 output branches. One of them is P1, other one is P4, other one is P7. So P1 plus P4 plus P7 should be equal to 1. Next, look at for state B. As you can see, from the state B, there are 2 branches coming out. One of them is this, and one of them is this. So that means P2 plus P3 should be equal to 1. In the similar fashion, if you go to state C, so from this state C, you can see that 2 branches are coming out. One is this branch and other one is this branch. So P5 plus P6 should be 1. That means P2 plus P3 is equal to P5 plus P6. So based on this, we can find out which is the right answer here. The first one is P2 plus P3 is P5 plus P6, correct. The second one is wrong. Why? Because P1 plus P3 is equal to P4 plus P6. We cannot tell this relation without the knowledge of P2 and P5. The second one will be true only if P2 is equal to P5. Second one will be true if P2 is equal to P5. So it is incorrect. Similarly, this one is correct one. I already told this. And last one is incorrect. So the correct answer is A as well as C, right? Let's go to the next question. I think this is a very simple one, a cakewalk. A 4:1 multiplexer is given with selection line CD, where C is the MSB and D is the LSB for the selection line. Output expression has to be C XOR D. For this, what should be the inputs? We know for a 4:1 mux, the output expression is given as C bar D bar I naught, C bar D I1, C D bar I2 and C D I3. We want F to be equal to C exclusive or D. That is, F is C bar D plus C D bar. So I need to get this term, I need to get this term. That's the reason I1 and I2 are connected to 1 and I0 and I3 are connected to 0. So the inputs are 0, 1, 1, 0. So that is the I0 to I3 values in this. Simple one, it's a 1 mark question here. X plus YZ is equal to which of the following? But only care you have to take it is, it's a multiple select question. Okay, you know that pretty well. X plus YZ using distributive law can be mentioned as x plus y into x plus z. So keeping that in mind, the correct answer, one of them is C. And even if you simplify this one, okay, x plus xy is equal to x. It is going to become x plus yz. So this is also right answer. Of course, the first one and second one, they are incorrect. So the answer to this question is C and D. It's a 1 mark question. Yes, earlier this question was solved in the form of a network theory problem, but if you remember, this is called as voltage switched R2R ladder DAC. Its output voltage equation is given by the gain of the amplifier multiplied by 1, 2, 3, 4 inputs are there. So this is A3 by 2, A2 by 4, A1 by 8, A0 by 16 into the reference voltage. So for any DTA type of converter, which is a voltage switched one, this equation you can use where K is the gain of the amplifier. Okay, that's it. So as you can see here, this is connected to 0 means, as I said, A3 equal to 0. This is connected to 1.6 volts, which is nothing but the reference voltage, means A2 equal to 1. Similarly here, A1 equal to 0 and here A0 equal to 1. So that's how you can interpret depending on the voltages here. So input is 0, 1, 0, 1. So substitute into this. And meanwhile, what's the gain of this amplifier is minus 1. So this is going to become equal to A3 is 0, leave it. This is 1 by 4, leave it, 0, 1 by 16 into 1.6 volts. Okay, so this is going to become minus 5 by 16 into 1.6. That is minus 1 by 2 volts, which is minus 0.5. So if you can recognize that it is a voltage switched R2R ladder DAC, and you can write this formula directly and obtain the answer directly for this. Okay. Yeah. With this, we have come to the end of the online session dealing the solutions of the GATE exam, and hope your answers match with the answers what I have given here. So behind this, there is a lot of effort from my colleagues. So I would like to appreciate them, and I want them to join with me, okay, and come in front of the camera. So I request all the faculty to please come over here. Kiran, Trinath, Srikanth, Sivasubramaniam, Vivek. Yes. So some other faculty, they could not join because of some other assignments, unfortunately. Okay. Right. So from our analysis, we feel that the paper is moderate. So final conclusion is the qualifying mark will be from 26 to 28. So anything if you get between those marks, you will qualify for the GATE exam. And if you want to get into IITs, after our long discussion on that, we felt that if you get anywhere between 50 to 55, so you can get into premier IITs, 50 to 55. So try to understand, hope that you have solved it to that level, because for all the platform GATE coaching, these type of questions were discussed thoroughly. So if you have followed the fundamentals well, I think you would have answered to this properly. I hope that all of you will get the admission into IITs. So wish you best of luck. I would like to listen good news from you. So wish you best of luck.
Wish you good luck.